Hello everyone, welcome you engineering chemistry class. Myself Bhagyalaxmi, Department of Chemistry in Marri Laxman Reddy Institute of Technology and Management. Today I am going to discuss about EDTA method. This EDTA method, it is also known as complexometric method. This is the second class of water and its treatments in engineering chemistry module 1. Estimation of hardness of water by EDTA method. What is hardness? Hardness means due to the presence of the calcium or magnesium ions which are present in our hard water. So due to this presence of the calcium and magnesium ions, it does not give the lather with soap solution, so it causes to the hardness. So when it is presence of the calcium and magnesium ions, it will give the different types of the hardnesses based on the presence of the carbonates, bicarbonates, chlorides, sulfides, nitrates of the water. So this hardness based on the presence of this bicarbonates, chlorides, sulfides of the water, two types of the hardness of water will be there. One is a temporary hardness, permanent hardness. So in this EDTA method, we have to find out temporary hardness, total hardness, permanent hardness. So estimation of hardness of water. Let us discuss what is estimation of hardness of water by EDTA method. This is also known as complexometric method due to the presence of the calcium and magnesium ions present in our water. And why this EDTA method? It is also known as complexometric method. EDTA means ethylene diamine tetraacetic acid. Ethylene diamine tetraacetic acid. Acetic acid. So in this EDTA means ethylene, two carbons, which is presence of this our two carbons ethylene. Diamine, di means two, so here it is in the two amine groups, and tetra means four, so here 1 and 2, 3, 4, so tetraacetic acid. So ethylene diamine tetraacetic acid, it is a chelating agent, means it is a complexing agent, pentadentate ligand. This pentadentate ligand which is reacted with the calcium magnesium ions, ions to get the complexes metal ions. Hence this titration, it is also known as EDTA, it is also known as complexometric method. Ethylene diamine tetraacetic acid. By titrating of the EDTA method with the help of EBT indicator, we have to find out the temporary hardness, permanent hardness and total hardness of the given sample of water. Sample of water means like any sources of water we should take in, then we have to find out how much hardness will be present in our sample of water. So by this our complexometric method. So in this we are using this EBT indicator. EBT means Erythrum black tea indicator. By the titrating of the EDTA and with the help of EBT indicator, find out the hardness. So whenever we should add this EBT indicator, the color should be the wine red color. And after the titrated with the EDTA, the color should be turns to the pale blue color. So this is the color will be changes to this in our EDTA method, wine red to pale blue color. So what is the EDTA and what are the types of EDTA methods? Then estimation of hardness of water by EDTA. First, metal ions. What are the metal ions will be present? Calcium or magnesium ions. And this calcium magnesium ions will be present in this our hard water. So what is the basic principle involved in this our EDTA method? This calcium or magnesium ions are interacted with this EBT indicator. EBT means erythrom black tea indicator. So whenever we should add this EBT indicator, the color will be that our EBT color wine red color. So wine red color complex. So metal ions are interacted with this our EBT indicator to get the metal ions unstable complexes metal ions formation. The solution color will be wine red color. This unstable wine red color solution will be interacted with the EDTA, means in our burette filled with the EDTA. So titrated against with the unstable metal complexes ion with this our EDTA. So this is an colorless solution, so which is interacted with this our unstable metal complexes EBT complex solution to form the stable metal complexes EDTA solution. With this color will be that colorless too. Then free indicator pale blue color will be there. So this is the reason for this our EDTA method. It is also known as complexometric method. So here first we should take in the conical flask hard water. So this hard water which is presence of this our calcium or magnesium ions. Okay, then we should add this EBT indicator, and in this we should add one composition, buffer composition. So what is the buffer and why we are adding this buffer solution? So buffer composition of buffer NH4Cl plus NH4OH, ammonium chloride and ammonia hydroxide. This is a metal complex solutions which are present in our buffer solution. And why we are adding this buffer solution? To maintain the pH. To maintain the pH, here it is equal to the 10. So we should add this again the EBT indicator and also this buffer solution. The solution color will be changes to wine red color. This is the wine red color, and this wine red color, it is an unstable complexes metal ion can be treated against with the EDTA to get this pale blue color. So this is the blue color solution. This is our end point of the solution in our EDTA method. Then go to what are the steps are involved in this our EDTA method. Actually, how many steps are involved in this EDTA method? In our EDTA method, there are the 4 steps. One is preparation of MgSO4 solution, and the second one standardization of EDTA solution. Third one standardization of total hardness. Fourth one determination of permanent hardness. So first we have to discuss step 1. Preparation of MgSO4 solution. So magnesium sulfate, weigh about 0.25 grams of magnesium sulfate, and then transfer into the 100 ml standard flask and through the funnel, and we should add distilled water. You have to add to this distilled water, dissolve the solution up to this our standard mark of the our standard flask. So make it into the 100 ml MgSO4 solution. Then you have to find out the molarity of MgSO4. So molarity of MgSO4 is equal to M1. M1 is equal to weight by molecular weight by 1000 by volume. So here we have to find out the step 1 molarity of MgSO4 M1. Weight 0.25 grams of magnesium sulfate and molecular weight 246.48 molecular weight of magnesium sulfate with hydrated ions, heptahydrated ions, then 1000 by, then when we prepared this MgSO4 solution 100 ml, so by 100 ml, so here it is in this our molarity of MgSO4 solution is equal to 0.01. So M1 molarity of MgSO4 solution we prepared 0.01 molarity. Then go to the step 2, standardization of EDTA. Standardization of EDTA. Actually this is our experiment. So here we are using of this our EDTA solution. So fill the burette. Actually this is an standard solution. So fill the burette with EDTA solution. fill the burette with EDTA. 50 ml of burette, fill this our EDTA solution. And in our step 1 we prepared already the MgSO4 solution 100 ml. From that 100 ml of MgSO4 solution, then you have to only taken out this 20 ml, transfer into the conical flask. So 20 ml of MgSO4 solution, transfer into this conical flask, add buffer solution to maintain the pH value and EBT indicator. What is the full form of EBT indicator? Erythrom black tea. So whenever we should add this EBT indicator, then the solution color will be the wine red color. Then already we filled with the burette our EDTA standard solution. So titrated against with this our EDTA solution. Then the solution color will be transferred to this wine red to pale blue color. So when it is reached to the wine red color to this our blue color, then immediately we have to stop the titration and see the our burette readings. So you have to see this our burette readings. Then here we have to see this what is the molarity and what is the molarity of this our EDTA solution. You have to find out this EDTA molarity in this our step 2. So how we have to find out this our molarity of EDTA from this our molarity of MgSO4 solution. So M1V1 is equal to M2V2. M2 is equal to M1V1 by V2. M1 means molarity of MgSO4 solution. We already prepared and we already calculated this our molarity of this our M1 value from step 1. Then here V1 from our step 2, from our end point, then we have to find out this our V1 value, volume of EDTA solution. And V2, what is V2? Volume of MgSO4 solution. So volume of MgSO4 20 ml we should taken in our conical flask. So from that all the values we have to substitute this formula. Then we have to find out this our solution. Solution M2 value. So M1V1 by V2. So from these all the values we have to substitute this formula. Then we have to find out the M2. What is M2? M2 is equal to molarity of EDTA. So this is our important step. Why? Because from this our EDTA solution only, our EDTA molarity only, then we have to find out the total hardness and also the find out the temporary and permanent hardness, step 3 and 4 only. Okay, so EDTA molarity, M2 is equal to molarity of EDTA. Then go to the step 3, standardization of total hardness of water. So in this directly we should take in this our sample of water, that is a hard water or any tap water or any sources of the water we should take in that only the 20 ml. So 20 ml of tap water transfer into the conical flask. Transfer into the conical flask, add EBT indicator. So EBT indicator, when we should add this EBT, then the solution color will be changes to the wine red color, and our solution EDTA we filled burette with EDTA solution and then titrated against with this our EDTA. Then this pale blue color solution will be turns to pale blue color solution will be turns to, wine red color solution will be turns to pale blue color. So here hard water, tap water, 20 ml of tap water taken into this our conical flask, add EBT indicator, and also we should add buffer solution, you maintain the temperature, pH value, then wine red color solution, the solution will be changes to the wine red color, then titrated against with the EDTA, solution will be turns to the pale blue color only. So after that we have to see this our end point. Okay, end point. Then we have to find out the M3 value. So what is the M3? M3 is equal to M3V3 is equal to M2V2. Here we have to find out the M3. So M2 is equal to M3V3 by V2. So what is the M3? M3 is equal to molarity of tap water or molarity of hard water. M3 is equal to molarity of hard water. And what is the E3? V3 is equal to volume of EDTA. When we are getting of this our solution color wine red to pale blue color, actually this every step we have to repeated the procedure for the 3 times, then you will get the concurrent values. Then you have to take that accurate concurrent value. From that we have to find out this our M1 value, M2 value, and also the M3 and M4 values. So here M3 hard water molarity, then V3 volume of EDTA, then here it is in the V2 means volume of our hard water or tap water. So volume of hard water or tap water we should taken in this our 20 ml only. Okay, so 20 ml here. See this first actually what is our step 3 standardization of total hardness of water. So M3 first we have to find out. Okay, M3 we have to find out. So here M3 is equal to, okay, M3 is equal to M2 V2 by V3, M2 V2 by V3, M2 V2 by V3, molarity of EDTA method and volume of EDTA and tap water volume, all the values we have to substitute this formula. Then we have to find out this our molarity of our hard water, molarity of our hard water. But here it is in the step 3, what is our aim? We have to find out this our total hardness of water only. So here how we have to find out this our total hardness of water? From the M3 value. So what is the formula? Total hardness is equal to M3 into 10 power 5 ppm, M3 into 10 power 5 ppm. So we already find out this M3. From that M3 then we have to multiply with the 10 power 5, then we are getting of this our total hardness from the step 3. So from the step 3 then we find out total hardness. Then go to the step 4. So let us discuss step 4. What is the step 4? Standardization of the permanent hardness of water or estimation of the permanent hardness of water. So here in this step we are using the boiled water. First we have to take this our sample of water or hard water in our beaker, 1000 ml of the beaker or any 500 ml of the beaker. Okay, so 1000 ml of the beaker. Then after that make it into the boiling process, or any 100 ml of the beaker, then make it into the boiling process. That 100 ml of the solution will be reaches to this or decreases to the up to the 50 ml of the solution. Then after this 50 ml of the solution will be filtered, then getting of the boiled water solution. Actually here what is our step? Determination of the permanent hardness. And why we are using this our boiling water only? Because temporary hardness can be removed by the boiling process. So we have to find out only the permanent hardness causing salts. So we have to find out only the permanent hardness. So here then we have to use it to this, if it is the using of the soft water or any hard water, so this hard water which is presence of the calcium or magnesium ions. So all the ions will be there, like temporary hardness causing salts will be there, permanent causing salts will be there. So we have to remove of this our temporary hardness causing salts. So how we have to remove? By the boiling process. So that is the reason then we have to removal of this our temporary hardness causing salts by this our boiling of water process. So 100 ml of water will be the decreases to the up to the 50 ml. Then that 50 ml of the solution will be taken out, and after that we have to filter, then getting into this our purity of the only the permanent hardness causing salts of this our water. So in that hard water we have to find out the permanent hardness. So how we have to find out? So that is our step 4, determination of the permanent hardness of water. So in this pipette out 20 ml of our boiler water, then transfer into the conical flask. Then after that we should add this our buffer solution and also the EBT indicator. Then the solution color will be the wine red color. Then our burette with the filled with the EDTA solution. Then this wine red color solution will be turns to the pale blue color when it is titrated with this our EDTA solution. Then you have to stop the titration and see the burette reading. Then you have to see this end point of the our burette reading. Then that is equal to the volume of EDTA solution. So from that volume of the EDTA, then we have to find out this our determination of the permanent hardness of water from our fourth step only. Okay. So see this permanent hardness. See here actually what is that formula? M2 is M2V2 is equal to M4V4. So M4 is equal to M2V2 by V4. M2 means we already calculated in the step 2 standardization of EDTA solution. So from that step 2 only we find out M2 value. Then V2 means volume of EDTA. What is E2? V2 volume of EDTA. And here what is V4? V4 means volume of the boiled water. So volume of the boiled water V4 we should take in this our conical flask 20 ml boiled water. Okay. So 20 ml boiled water V4 value, and V2 our end point of this our burette reading. Then M2 is equal to from step already we know that if it is getting of this any 0.01 or whatever we will getting of this our reading, then you should write that M2 value. All the values we have to substitute this our formula, then we have to find out this M4. So what is the M4? M4 is equal to molarity of the, okay, M4 is equal to molarity of boiled water. But here what is our aim? Determination of permanent hardness of water only. So in this we have to find out this our permanent hardness, M4 permanent hardness. So here M4 boiled water molarity with the help of this M4 value. So permanent hardness is equal to, okay, permanent hardness is equal to M4 into 10 power 5 ppm. M4 means from our step 4 we find out M4 molarity of boiled water. So it is multiplied with the 10 power 5, then we are getting of the permanent hardness from our step 4. So step 1 we find out the M1 molarity of MgSO4. Step 2 we find out molarity of EDTA. Step 3 we find out molarity of tap water. Step 4 we find out molarity of the boiled water. So all the M1, M2, M3, M4 we find out this our total and temporary permanent hardness of water with the using of this hardness formula, means it is multiplied with the 10 power 5 in our ppm hardness units. Ppm means parts per million. Okay. So from our step 4 we find out this our permanent hardness. Step 3 we find out the temporary hardness. So what is the total hardness? Total hardness is equal to temporary hardness plus permanent hardness. So total hardness we find out from the step 3, permanent hardness find out from the step 4. We have to find out the total temporary hardness also. So temporary hardness is equal to total hardness minus permanent hardness. Total hardness minus permanent hardness. So from our formula, then we have to find out the temporary hardness. So step 3 find out or determination of this our total hardness. Step 4 determination of the our permanent hardness. Step 3 and 4 with the help of these two steps we find out temporary hardness. Temporary hardness is equal to total minus permanent hardness. So these all the steps will be in our EDTA method or nothing but a complexometric method. So in this complexometric method we find out the total hardness, temporary hardness and permanent hardness. So these are all are my references in our session. With the help of these all the references I use this our class. In this class only estimation of hardness of water by EDTA or complexometric method session. Thank you one and all. Thank you all of you.